Swayam Prabha. Digital India. Educated India.
Okay, I think one of you has answered this. If you have a current somewhere dependent on voltage elsewhere, clearly it's a voltage controlled current source. Okay, so this is a voltage controlled current source. It says that the current going into port 2 in this direction, this is I2, right? So always keep in mind that this I1 and I2 are currents flowing into the ports. It's a voltage controlled current source which is controlled by V1. Okay, so this I will write Y21 V1. Okay, so it's a voltage controlled current source controlled by V1 and connected across 2 prime in this direction. Okay, now similarly, if I take the other terms Y12 V2, the current in port 1 is dependent on voltage at port 2. Okay, so clearly here also we need a dependent source, and finally this term, the current in port 2 is dependent on voltage at port 2. So current and voltage are at the same port, so we can use a conductance which is Y22. Okay, so this is an equivalent circuit representation of a two-port network. Okay, any linear two-port can be represented like this. That's the advantage of this. See, the point of having all these representations is that I think I have repeated this many times before. You will end up designing very complex circuits which have lots of components. Now, the person who is using that may not need to know all the internal details. So, let's say you have this black box which has hundreds of resistors and control sources and whatnot, but it has only 2 pairs of terminals brought out. Okay, so someone who is using this doesn't need to know all the intricacies of the circuit inside. They only need to know the current voltage behavior at the terminals. Okay, so as long as you have only 2 ports exposed to the outside world, they can be represented by just 4 numbers: Y11, Y12, Y21, Y22. Okay, and anyone doing any analysis of this black box or any other system using this black box can use those 4 numbers to do their analysis. Okay, or equivalently, they can use this 2-port equivalent circuit, this thing I have shown here, to do their analysis. Okay, so however complicated the circuit is inside, it can be replaced by this much. Okay, of course you have to find the value of Y11, Y12, Y21 and Y22. Okay. Is this clear? Any questions about this? So this is analogous to, in case of 1 port, I can always represent it by a single resistor. In case of 2 ports, I need 4 parameters, because there is a resistance across 1 prime, there is a resistance across 2 prime, but also if you apply something to 1 prime, it affects something at 2 prime. Similarly, you apply something to 2 prime, it affects something at 1 prime. Okay. So with all these interactions, we will need 4 parameters to describe a 2-port network. Okay. Any questions about this? Okay, the question is, how do you say it is a voltage controlled current source? Because the current is a function of a voltage, so it is, this is the input, this is the output, so to speak. So it is controlled by this voltage and gives you that current. So it's a voltage controlled current source. Okay. So one of the questions is, what is the use of these parameters? As I said, you can describe a complicated circuit, however complicated it is inside, to overcomplicated its inside with these 4 parameters. That's the use. Basically, it's a representation. And also, you could have 2 different circuits inside. Okay, but let's say you have 2 black boxes. Each of them has 2 ports, and the internal details are different. But if the Y parameters are the same, so that means that they will behave equivalently. Okay. So you could have one circuit with 100 resistors, the another one with 50 resistors, and if you arrange it such that the Y parameters are the same, then if you use this black box in some other circuit, they will behave identically. Okay. So basically, it's a matter of representation, and it turns out that more complicated circuits like more complicated devices like transistors, which you will encounter later, which are used to make amplifiers and so on, can be represented using these Y parameters or some other 2-port parameters. Okay. So the other question is, why do we have a conductance here? See, if you have a current at some pair of terminals proportional to the voltage at the same pair of terminals, it has to be a conductance, right, or a resistance. Okay. So if the picture looks like this, you have 2 terminals. The voltage here is proportional to current there, or the current there is proportional to the voltage here. So it means that the equivalent thing is a conductance. Okay. So now let's take an example. Okay. Let's take a simple example. So this is my circuit. This is port 1 and this is port 2. So please find the Y parameters of this. Okay, and then you can give me the answer by typing it into the chat window. First of all, please find the value of Y11. Again, to do this, you can recall the definition. There are many ways of doing it. First of all, you can apply voltages to both sides, find all the currents, and obviously it will be in this form, and you can find these numbers. Okay. Alternatively, you can use the definitions we came up with earlier, that Y11 is conductance at port 1 with port 2 short circuited, and Y21 is transconductance from port 1 to port 2 with port 2 short circuited, and so on. Okay. So first is, please give me the value of Y11. There is an answer from Aarti, but it doesn't seem to be correct. So please take note of the values correctly. So this is 2 kilo ohms, 2 kilo ohms, and 8 kilo ohms. And how will you find Y11? What will you do to port 2? And one more thing I have to point out, which also I have mentioned repeatedly, that please try to get a feel for the numbers and always give numbers with units where applicable. Okay, we would never say that the distance between Chennai and Bangalore is 360, right? It is 360 kilometers. So similarly, whenever you have quantities with dimensions, you have to include the appropriate unit. Okay, because if I just say 360, it is not clear if it is 360 kilometers or meters or millimeters or whatever it is. Okay, so always give the number with the appropriate unit. Okay, so 1 millimho, or usually I prefer to say Siemens for the unit of conductance. So this is 1 milli Siemens. Okay, how do we get this? You short circuit port 2. Once you do that, this 8 kilo ohm goes out of the picture, it is short circuited, and you see that this 2 kilo ohms and that 2 kilo ohms are really in parallel with each other. Okay, so looking into 1 prime, we have 2 kilo ohm parallel 2 kilo ohm, which is a 1 kilo ohm resistance, but Y11 is the conductance, so 1 divided by 1 kilo ohm is 1 millisiemens. Okay, similarly now, what is Y21? Please find the value of Y21. I mean, I jumped to Y21 because it's also measured with port 2 short circuited. Okay, I think a couple of you gave the right answer immediately. It's 1 millisiemens again. But one of you has said it is 1.6 millisiemens. I'm not sure how you got it, but that is not correct, because if I apply V1 here, now what I have to measure is, first of all, the current I2 measured in this direction. Okay, so keeping this in mind, please give me the correct answer. I2 is measured going into the network. Okay, by definition, that's how I1 and I2 are. I1 and I2 are. Okay. What is the value of Y21? So I need not only the correct magnitude but also the sign. Okay, so let's look at this carefully. Here, this is short circuited. So all of this V1 appears across this 2 kilo ohms. Okay, because port 2 is short circuited. So the voltage here is V1. Okay, so a current V1 divided by 2 kilo ohm will flow in this direction. Okay, so now what is V1 divided by 2 kilo ohm? It is V1 times 0.5 millisiemens. Okay, so this is the 8 kilo ohm is not in the picture. Okay, so this is short circuited. So if I apply V1 here, all of it appears across this 2 kilo ohm, and V1 by 2 kilo ohm flows in this direction. Okay. Also, this direction is opposite to that of the definition of I2. So what is the value of Y21? it is minus 0.5 millisiemens. Okay. I hope this calculation is clear. If it is not, please let me know immediately so that I can repeat how to do that. Okay, so what is Y21? I apply V1 to port 1 and I short circuit port 2 and I measure the current through the short circuit. Okay, so that is the current in port 2 and in this direction going into this terminal 2. Okay, so now what is the circuit I have? Inside this box, okay, so that is the two port network and these are the terminals and I apply V1 here and this part is short circuited. Okay, so I hope it is very clear that V1 is applied here, so the voltage across this is V1 and similarly this is short circuited all the way through, so the voltage across this is 0, right? 8 kilo ohm is connected in parallel with the short circuit and V1 appears across this 2 kilo ohms. Okay, so V1 appears across this 2 kilo ohms. Now the current through this 2 kilo ohm resistor is V1 divided by 2 kilo ohms. Okay, when it appears at this node, it can go either through the 8 kilo ohm or the short circuit. Obviously, if you have something in parallel with the short circuit, everything will go through the short circuit. Okay, this you can easily calculate. I mean, see from the current divider theorem. So if you have something across a short circuit, all of the current will go through the short circuit. Okay, so this V1 by 2 kilo ohm is what flows out like that. And remember, this I2 is what we are trying to measure going into the network. Okay, this I2 is what we are trying to measure. So I2 will be minus V1 divided by 2 kilo ohms. Okay, and this is nothing but Y21 V1. Okay, so Y21 is minus 1 by 2 kilo ohms or minus 0.5 millisiemens. Okay, so that's how I get the value of Y21 to be minus 0.5 millisiemens. Is this okay? I think one of you has got the answer of minus 12.5. I think it's some simple numerical error. Okay. Now there is a question, what is the significance of negative admittance? This is not admittance. Okay, we are not looking at voltage at some port divided by the current at the same port or current at some port divided by the voltage at the same port. Okay, so that would mean something significant. A negative resistance there means it is generating power. Here, if here we are talking about current at port 2 divided by voltage at port 1. This being negative doesn't have any particular significance. Okay, later I will show how very easily we can make that positive. Okay, so with this background you should be able to calculate Y12 and Y22 quite easily as well. So please give me the values Y12 and Y22. So you have to be able to calculate this for any circuit. Okay, So again, all this requires is a systematic circuit analysis. You short circuit port 2 and apply V1 to port 1. Then you can calculate Y11 and Y21. You short circuit port 1, apply V2 to port 2. Then you can calculate Y12 and Y22. Okay. So please give me the values of Y12 and Y22. Okay, please calculate Y12 and Y22. Okay, Aarti, you got 0.625 millisiemens. Again, there is some calculation error. Please make sure that you, sorry, with this one, this is Y22. Okay, so yeah, Y22 is 0.625. Yeah, that's correct. So that is the correct answer. What about the value of Y12? Sumit has got minus 0.13 millisiemens. This is not correct. Okay. Please check your answer. Remember, Y12 is I1 divided by V2 with port 1 short circuited. Okay. No, it is negative. That's okay. But even the number is not correct. The value of Y22 is 0.625 millisiemens. That's correct. Okay. What is the value of Y12? So to calculate Y12, you have to apply V2 to port 2 and calculate this current flowing in port 1. Okay. So again, I think Sumit has got it right. So it is minus 0.5 millisiemens. Okay. So the Y parameters of this network are 1 millisiemens, minus 0.5 millisiemens, minus 0.5 millisiemens, and 0.625 millisiemens. Okay. So this and this we already discussed. We'll look at the other two. To calculate Y22, what we do is we have to short circuit port 1 and apply V2 here. Okay. Now, you see that this 2 kilo ohm is in parallel with 8 kilo ohm. Okay, because this is short circuited. So this 2 kilo ohm is in parallel with this 8 kilo ohms. Okay. So essentially you see a conductance corresponding to 2 kilo ohm in parallel with 8 kilo ohms. Okay. I2 by V2 will be 1 by 2 kilo ohm parallel 8 kilo ohm, which is 2 kilo ohm times 8 kilo ohm, 2 kilo ohm plus 8 kilo ohms. Okay. This is 10 by 16 and you have kilo ohms in the denominator, so it is millisiemens. So this is 0.625 millisiemens. Okay. And to calculate Y12, what I have to do is to find this current, sorry, I1, okay, as a function of V2. I apply V2 and find I1. So again, you see that this V2 appears directly here, and also because this is short circuited, V2 appears here. So the current flowing from right to left through this 2 kilo ohm resistor is V2 by 2 kilo ohms. And at this node, you have the short circuit and the 2 kilo ohm. So obviously all of the current will go that way. So I1 is minus V2 by 2 kilo ohms, which says that Y12 is minus 0.5 millisiemens. Okay. So we end up getting this set of Y parameters. Okay. So now, first of all, is the procedure clear to everybody? I think many of you made mistakes while calculating. Please avoid that. With a little bit of practice, you will be able to avoid those things. Okay. So please mind the units like kilo ohms and millisiemens and so on. And also, please mind exactly where the current is flowing. Okay. Because when you short circuit it, some of the components drop out of the picture. Is this okay? Calculation of Y parameters? Okay. Now, my question is, Y12 and Y21 came out to be exactly equal, minus 0.5 millisiemens. So, now my question is this a coincidence for this circuit, or what do you think it is?